All right, so today we're going to talk about geometric sequence. And you guys have done arithmetic sequence. Does anybody remember when you guys do an arithmetic sequence, what's happening? Adding. Good. It's adding with a pattern. No, you're right. It's pattern too. It's a pattern. Now look at this one. What's going on here, though?
Doubling.
Doubling. Good. So what is like doubling? What kind of operation is that? Times 2. Good. All right. Awesome. Yeah, we're multiplying by 2 each time. So if you guys did the next number, what would it be? 83. Awesome. All right. So what do you guys think geometric is then? And arithmetic adding, what do you think geometric does? Multiplying. Good job. All right. So geometric sequences are going to be multiplying a certain amount every time. The formula I'm going to give to you guys, right? If you're taking a reasons class, you need to like memorize it, but you don't need to here. What you're going to be multiplying every time is going to be called the common ratio, and that's going to be like an R. You know how in the arithmetic, what you were adding was like the D, it's called the common difference in your formula? This time, it's just going to be the R in the formula. So if you guys look and see what's going on this time in your pattern, what do you think we're multiplying by? Ooh, that's good. Times a -2. I like it. Good job. See how it goes from negative to positive, back to negative, then to positive? Right? When that happens, when you guys get the alteration in sign, it usually has to do with something being multiplied by a negative number. It's the only way you can get that kind of pattern. So if we did the next number, we don't need the next 3 terms. It's kind of a waste. Let's just do the next term. What do you guys think the next one would be? How would you do it? What would you have to do? Times -2. Geez, would you guys do that? So you can do it. Okay. -126. Nice. -176. Perfect. Good. Good, good. All right. This next one's a little easier. What do you guys think for this one?
We multiply by 5.
By 5. Awesome. Nice. Each one we're timesing by 5. Great. All right, so we take 125 and we times it by 5.
625.
Oh, good job. Perfect. Right. And notice how like your numbers are getting really big, right? When you guys are doing multiplication, that's okay. They're going to get really big. Multiplying increases much quicker than adding or subtracting. All right. So here's your formula we're going to use, all right, for a geometric sequence. Okay. So if you guys see multiplication going on between your sequence, we're going to have to use this formula, right? And again, I will give you guys all your formulas. You just have to know how to like use them. So 8/1, right? That's going to be the first term in the sequence, just like the last sequence we did was. R is the common ratio. Okay, that's what you multiply by. Okay, and N is going to be the term you want to find. All right, so whatever term they ask you for. So here's a little example. Find the nth term of the sequence, then find the 7th term of the sequence. All right. Well, if it says anything about the nth term, do you guys remember what we kept n as? N. Nice, Mary. Good job. All right. So keep n. So let's see. If we're going to find the nth term, what we first need to figure out is what's going on here. Timesing. Are we timesing or adding? Timesing. Good. Okay, so we are multiplying. That's going to be the way you guys tell the difference of which formula to use. You want to see first, am I multiplying or adding? Since we're multiplying by 3, okay, that means we have to use this geometric sequence formula, right? A sub n equals a sub 1 times r, the n minus 1. Okay, this n minus 1, guys, so we know when we're putting it into a calculator, this whole thing is an exponent. Right, so we're going to have to use our little caret button. Right, so let's fill some things in here. What is the a sub 1? What's our first term? 2. Good, so this is going to be 2 times. What were we multiplying by? 3. Good, so that's your r. So the r is going to be the 3. We'll put that in parentheses to kind of help us. Nice, and we're going to keep n for the first one. Awesome, great. So this is going to be our nth term of the sequence. Now, if it asks you guys to find a specific term, like this one says, then we need to find the 7th term of the sequence. Bless you. So bless yourself.
Thank you.
So if you guys want to find the 7th term, what do you think n is going to be now? 7. Good job. We're just going to put the 7 in. Right. Now when we calculate this, we got to be really careful with PEMDAS. Simplify your exponent. Yeah.
Oh, okay, that's what I was going to ask.
Oh, yeah.
Can I ask if you get simplified before you start your calculator?
And I would actually suggest that because your calculator gets a little bit like weird with the PEMDAS itself. You want to have to help it. 7 minus 1, yep. I just put in a 7 now because we want to find the 7th term. That's why the n is 7. Okay. That can change if I want to find like the 12th term, this would have been a 12 minus 1. Okay. So let's simplify. Yep, make this a 6. Now what do you guys do first? Do we multiply or do we do exponent? Good, exponent. Now you guys have two choices the way you put this in. Okay. You could do 3 to the 6, because we have to do the exponent first, and then times that by 2. Okay, so you could do that. Or if you put the 3 in parentheses, we could do it all at once. So you could do it this way too. Okay. By putting those parentheses in, it kind of tells it if you want to use the 3 to the 6 first. Right? See how we get 1,458 both times?
Yeah.
All right, so either one is fine, but just make sure you guys are careful with your PEMDAS. Okay. We got 1458.
We just write it.
Well, as long as you guys do your PEMDAS, it doesn't really matter which way you enter it in the calculator. What do you guys think so far? Great, not too bad. You're kind of just like using the formula, which is good. Right, so this next one's a little tricky. If you want to find a sub 8, what does that mean? Eighth term, good. Nice job, guys. Right, so let's figure out what the heck is going on in here. It's a little bit tricky to figure it out. We're multiplying, adding. You think we're multiplying, right? I think so too, because see how you're increasing very small here and it's getting bigger? Think by 7? How did you guys figure that out so fast that you were timing by 7? Yes, oh my gosh, Abby, that is the key here. Right, this is really great. If you guys could, if I look at this, this is pretty tough to see like what you're multiplying by, right? Just to look at it and tell, that will always work. So if you guys can't tell what you're multiplying by, you have tricky stuff, pick one of them. Doesn't matter which one. All right, and then you're going to divide by what's right before it. So if you take 24.5 and you divide by 3.5, you should get it's 7. So that's an easy way to tell what you're multiplying by, right? Kind of undoing it. You were just hitting random ones? Okay. This will always work though. Abby, that was great. So, good job. All right. So let's see if we're going to use our formulas now. We know we're multiplying by 7. A sub n equals a sub 1 times r to the n minus 1. What do you guys think that we're going to put in for a sub 1 here? Good job. 0.5, just 0.5 works. You want to do 0.5, that works too. All right. What's your r going to be? 7, good, because we're multiplying by 7. Okay, and now since we wanted the 8th term, what is the n going to be? 8. Good job. So I'll put this in here for the 8. Okay, let's figure out what this is going to be. Try it out. Make sure we simplify the exponent first, like Nick was saying. Make that 8 minus 1 is 7. Okay. Then watch your PEMDAS. Did we get, yeah? It's 411,771.5. 411,771.5. Let's see if you, oh, actually, let me just make it tough for you. See if you guys can figure out, for example, 5, which one this is going to be. This is tricky. What is the formula for the nth term? Right. And remember, when you guys see that nth term, remember n stays n. You could use Abby's little trick here too. Yeah. Think about maybe as a fraction though, what that would be at. Ooh, good. All right, so we're all kind of thinking.
You can have it be division, not multiplication.
Okay, I love what you guys are. Okay, so we all, I think, are thinking. I keep seeing this on your papers, divided by 3, right? Divided by 3 is very easy to see here, but we want to organize it as multiplication. Do you guys remember back when we did division? What did you really do? What was your rule for division of fraction? Do you remember?
What?
Do you remember this?
I'm singing a joke.
Oh, great. Anybody remember division of fraction? Yeah, we put it over once. Yes, good job, Ann. You're on a roll today. All right, remember the copy and change flip? So if you guys imagine this, we change division to multiplication and then you flip the fraction. So if you're dividing by 3, what's it really the same as? Multiplying by 1/3, right? So here, the R, what you guys are multiplying by is going to be 1/3. Now, if we weren't sure about that, remember Abby's little trick from up here? Right? She said just take one of the numbers and divide by what comes right before it. So if we take any of these terms, if I take like 18, then I divide by 54. So if I took, let's see, 18 divided by 54, and I use my math fraction key, see how that'll give you 1/3? So if you guys are ever not sure what we're multiplying by, just take one of the numbers, divide by what comes right before it. It'll always work, no matter what. So now that you guys know your R is 1/3, which one do you think it is? Which one will go like with your formula? You say 4 over here. Anybody with a 3? No, 1? 2? No? Okay, so we're all in agreement? Definitely choice 4. Good job. Because your 8th of 1 is your first term. You've got our 1/3 in there, and you've got the n minus 1 from the formula. Good work. All right, here is a super challenge problem. We're not going to do the last one here. What is the common ratio for the geometric sequence whose first term is 27 and the fourth term is 64? It'll be the last one we do. Right, this one's tough. Now, it's kind of nice because you do have multiple choice here. Right? If you need to give yourself like a little picture, your first term is 27. You don't know what e sub 2 is. You don't know the third term, but we know the fourth term is 64. They want to know the common ratio. So what that means is we want to figure out what do you have to multiply by every time to get 64 for the fourth term. Let you guys kind of ponder this and kind of see how you handle it, and then we'll go over it. There's a lot of ways I think you guys could start this one. It might be done. Alright, what ways are you guys kind of thinking? Anybody doing guess and check? Yeah, you're doing guess and check? Right. Now, one thing that you guys could do to get rid of some of these kind of quick, if you're multiplying by 3/4, that's like 0.75. Would your numbers get bigger or smaller? Smaller. If you're multiplying by something that's less than 1, your numbers would have been decreasing. So look at what you have, 27 to 64, increasing. So it can't be 3/4. Is 64 over 81, is that smaller than 1?
Yeah.
Yeah, because remember, 1 would have been like 81 over 81. This is smaller, so it can't be that one. Now, we are down to these two. So if you guys are someone who's guessing and checking, we can take this 27 and multiply by 4/3. We would get 36. So that means this one would have been 36. And then let's see if we take that 36 again and times that by 4/3. We get 48. Yeah, it's a difference. And then let's see, times that by 4/3. Oh my gosh, we get 64. Alright, so it has to be 4/3. So that's one way. If you guys have something that's like a multiple choice, can you guess and check it? Yeah, you guys just did it, right? Does anybody know how you would have to handle this if you want to do it algebraically? What would you have to use? Does anybody know?
Fraction. What was the question?
What would you guys have to use if you wanted to do this algebraically? If you didn't want to guess and check. I'll use it. Alright, you have to use your formula. So if you guys didn't want to guess and check, we'd have to use this to figure it out. Now, we're missing the R. We didn't know, well, I do now, but we didn't know what the R was here. And we kind of have a lot of missing information. The only thing that you guys knew, though, for sure, was the fourth term was 64, and the first term was 27. So think about this. If this is your fourth term, right? Do we know what the n would be there if you're using this term for something? Do you know what term that is?
4.
The fourth one, good. So you can put a 4 in for the n. What's your first term in the sequence? Do we know that? Good, we knew this was 27. And then when you put your 4 in, what number did you get out? What was the fourth term actually? 64. So the eighth of, this would really be like saying eighth of 4 is 64. So if you guys started it like this, you can net this with 3. How would you guys separate a 27 from the R cubed? Divide. Good job. Right? So we have 7. So we have 64 over 27 equals R cubed. If you had something squared, I know we didn't get into a lot of cubic roots here. If you guys had something squared, how did you get rid of it? Square root. So if you have something cubed, what do you think you have to do? Cubic root, right? It is the thing, right? So if we took the cubic root of this whole thing, you have a button in your calculator that's a cubic root button. You go to the math key. Yep. See choice 4. How you have like a little 3 out there? So you can just do choice 4 and then type in 64 over 27. Hit enter. And use our math fraction key. You get 4/3. So both ways work. I know you guys, we didn't do a lot of cubic roots in here, but we do this. Great job. You guys did awesome.